हाय, चलो अब गेट का क्वेश्चन नंबर 34 भी देख लेते हैं। इस क्वेश्चन के अंदर हमें कुछ डेटा पॉइंट्स दे रखे हैं यहाँ पर, और हमें बोला गया है कि हमें y इज इक्वल टू डब्ल्यू एक्स लीनियर मॉडल फिट करना है यूजिंग द लीस्ट स्क्वायर रिग्रेशन मेथड. So for the least square linear regression, we have a direct form or the closed form solution which is given by the normal equation, which is expressed as x transpose x inverse x transpose y. यहाँ पर x is a features matrix and y is our labels. So जो डेटा पॉइंट्स हमें दे रखे हैं, द एक्स कोऑर्डिनेट इज आर फीचर्स एंड वाई कोऑर्डिनेट इज आर कॉरेस्पॉन्डिंग लेबल. ठीक है, तो अब हम एक्स ट्रांसपोज मैट्रिक्स पे से स्टैक कर लेते हैं. सो एक्स इज गिवन बाय -1 2 एंड 3. सिमिलरली वाई को भी हम एक मैट्रिक्स में स्टैक कर लेते हैं एंड इट इज गिवन बाय 1 2 सॉरी 1 -5 and 5. These are our labels. And now we can use this x and y and put into the normal equation to get the w. So w is given by x transpose x inverse x transpose y. So it is basically -1 2 3 and its dot product with -1 2 3 and this का inverse into -1 2 3 -1 it is 1 -5 and 5. So this is our y label, this is our x vector. And if now we go and solve this, so this is basically just a dot product. So it is 1 plus 4 plus 9 inverse, and this value would be -1 -10 plus 15, and this value would be 9 plus 9 plus 1 plus 4 is 14 inverse, and this value is 15 minus 10 minus 1 is this is 4, or basically we can rewrite this as 4 by 14, which is given by 0.2857. So the answer to the question is 0.2857. Let's look at the another way how we can solve this question. This would be the another way to solve this, and for that we'll do some sort of a derivation. And the reason is what happens if we forget to this particular form and we don't remember. So as always in another way or another solution, so it says that we have to solve it via the least square method, right? So least square is the, so let's note it first thing. So the model which we are fitting is y hat can be written as wx, where y hat would be the predicted label, okay, and y is the label which is given to us in the data. We are given with x comma y, right? So x would be our features and this is labeled. So if we multiply this x with w, we get a y hat, and this is actual y. So what we want is the error, the difference between y hat and y to be minimum, and that's the least square method. So what we want is y hat minus y ka whole square, and for each data point we want. So this for one data point, this is what we want, and we want this value to be we want this value to be as minimum as possible, and we want this for all the data points. So we have, for in our example, we have uh, three in our question we have three examples. So for all the examples we will sum it. So this is the least square formulation. Now we want to find the minimum value for this. So in the question is also that, so that least, so we need to find the minimum value for this. तो इसके लिए हम क्या करते हैं, एंड सबसे पहले तो y hat हमें पता है इज wx, so we can rewrite this as summation I y hat is wxi. So for each example xi would be different, and that's what it is. So we have, for each example, we have also subscripted each y and y hat and y with it I, minus y I ka whole square. So this is the function which we want to minimum value for. So let's call this as a function of w, which is given by summation I wxi minus yi ka whole square. When we want to find the minimum value, we can differentiate it with respect to w. So when we differentiate it with respect to w, the differentiation can look like, so it's some value cos to the power x 2. So we will, the differentiation would be, and we are differentiating with respect to w, so the differentiation would be this. So this would be the differentiation with respect to w. And now to find the minimum value, we can equate this entire equation to 0, and let's try to solve this particular expression. We can put this, we can since 2 is constant, we can take it to the RHS, and summation can be put inside. So it would be summation I wxi square minus summation I yixi is equals to 0. And now since w is a constant, it doesn't depend on I, so we can take w outside, summation I xi whole square, and this term can go to the RHS, summation I yixi, right? So from this we can say that w is equals to sum over all the examples of yixi divided by sum over all xi squares. So we can use this formula to calculate the optimal w. And if you see the examples which are given to us here on the top, and the question is minus 1 2 3. So it is minus 1 2 3, and I think the values of are minus 1 5 and 5. So these are the three data points which are given to us. So we can just say, first on the numerator we have to multiply x and y and sum over it. So we can just say minus 1 into 1 plus 2 into minus 5 plus 3 into 5 divided by xi is ka square. So it would be 1 plus 4 plus 9, which again comes out to be, so this value would be minus 1 minus 10 plus 15 divided by 14. So you see this expression is same as what we got when we used the normal equation. So here this can be written as 4 by 14, and so the answer is 0.2857, and that's the answer. So there we have discussed two ways to solve the particular question. One is via the normal equation. So this, if you remember the normal equation, directly you can get the x matrix and y matrix and put that into the normal equation, solve that equation, we'll get our answer. So that's when you know the formula. The another solution which we discussed was when what if we forget the formula and we have done an entire derivation on how to solve for this particular case, and we got the same answer for both the methods, and the answer to the question is 0.2857.